so let's just see what the shift does to our, this is what's going to be the general shape for all our exponentials. Okay? Let's start really low and let's go really high really fast. Okay? So what does A do? Right, increases the steepness, makes it narrower, wider, press percentage. What if it's negative? It reflects over what?
The x-axis.
The x-axis. We need to pay attention to that because we're going to have another kind of reflection here in a second. What's the H do?
Go up and down. No, go right, left, right.
Left and right. And what does K do?
Up and down.
Up and down. Okay. So it's just giving you guys an idea of what it looks like. Cool?
Cool.
So for all our parent functions, okay, we need to find a point that's in common. Does anybody know the point that's in common?
0, 0.
Well,
Where it crosses the y-axis.
okay. How do you know that?
When it goes across the y.
Well, let's take a look at a couple. We have 2 to the x, we have 3 to the x, 4 to the x. So when we're trying to graph these, how are we going to find the points? How have we done it before? Use what?
X, Y chart.
X, Y chart, table. Let's just use the table. What's a point you guys want to use?
0, 0.
Let's do 0. Plug in for x. What's 2 to the 0?
0, 0. 1.
1. Any number to the power of 0 is 1. So we have 2 to the 0 equals 1. What about 3 to the 0? What about 4 to the 0?
1.
You guys notice something?
They all are 1.
So all parent functions pass through what point?
0, 0, 1.
0, 1. So they all have that point in common, but then what happens if we go on to other points? Are they going to be the same or going to be different? Or going to be different? Why?
Because the x changes. Oh no,
Well, the x does change, but what's different here?
the basis.
Different bases, okay? Because we're at different bases, the y values are going to change with different x's, different x's. So number 9. What do you guys think is going to happen if b is between 0 and 1? Well, that is between 0 and 1, so what do you think is going to happen, Anthony? No idea? Someone give me a guess. I'll round up.
The graph will form the x-axis.
Say that one more time.
The graph's on the x-axis.
Does the graph sit on the x-axis? That's a good guess. Let's take a look and see what happens. Uh-oh.
I don't know.
What's happening? It is going down now, so now it's a, what kind of graph? Okay. So the K's is also going number 9. Or 9. What else happens?
Which tile?
All of them. So originally we had a graph looking like this, right? So what are we going to say? Not flip, we're using another word, but it's the same idea. What's the R? Reflects. Reflects over the y-axis. So now we have 2 kind of reflections. So now we have 2 kind of reflections.
Question.
Yes, sir.
Is that become negative? Like the graph will become negative?
It starts decaying because as we get larger, we get smaller. Okay? Because 4 is larger than -4. Wouldn't you say so? So we start off really high when we're small, but as we get larger, we're getting much smaller y values. So now it's a decay. Yes, sir. The y-axis. Well, we said that b is between 0 and 1, right? So if it's in between 0 and 1, it's going to reflect over the y-axis. And we're about to see an example of what happens when you have a b that is greater than 1, and then what happens when you have it in between 0 and 1. Yes, sir.
When it keeps going down, does it ever start getting negative?
Like negative y values?
Yeah.
With these, no. It would have to be flipped over the x-axis, and we're going to talk about that tomorrow. Okay? That's something, that's an idea to talk about. It will never go past 0. Okay?
Is it gonna change from time?
What do you mean? Like, is it ever going to go past that?
Yeah.
Nope. Never will.
No, less than no.
Nope. The only time that it'll be less than 0 is if it's reflected. Okay? So what are you guys noticing here? So we have our 5 to the x, e to the x, 2 to the x. This is number, no, not number 10. Number 11. This is number 11 on the other side.